So, it is my great pleasure today to introduce our speaker, Robert Seyfarth, who is coming to us from the University of Pennsylvania. I know we don't do long introductions here, so I'll just give a tiny little nugget to say that I know that Robert has many connections with many folks in this room, but personally, he was my external advisor for my undergraduate thesis, and so that was a very exciting moment for me to launch into the world of studying communication and primates. So I'm very grateful to both you and Dorothy for launching that interest in my own work. So today he will be talking about the social origins of language, and please join me in welcoming our speaker.
Thanks very much. It's really a pleasure to. I just remember this room in the room in which we had faculty meetings, and of course that induces an enormous amount of stress. But I'll try to get over that. Language has always been a problem for evolutionary theory because there's such a sharp discontinuity between the communication of non-human primates and human language. Just to go over the differences so that we get them on the table, in non-human primates, monkeys and apes have relatively small repertoire of calls, limited acoustic modifiability during development. They make few call combinations, and as a result, they've got a limited repertoire of signals. Language, of course, is completely different. There's a large repertoire of learned modifiable sounds. Words with independent meaning are combined according to grammatical rules, and they play functional roles as agent, patient, and action in sentences. A finite number of elements can produce an infinite number of messages. It's a discrete combinatorial system. And these stark differences that I don't want to minimize at all have caused a lot of people to sort of throw up their hands and say the first step toward human language is really just a mystery. I'm going to take a slightly different perspective on this and talk a bit more about some of the areas in which there seem to be continuities between the communication and cognition of non-human primates and that of humans. And I'm going to talk about three areas in which these continuities can be found: continuities in brain mechanisms, continuities in social function, and continuities in cognitive mechanisms. We know that there are a lot of areas in which the brains of monkeys and the brains of humans share homologous functional areas. So, for example, there's a specialized area for recognizing faces in the human brain, and there's a similar area in monkeys. There's also a specialized area for the recognition of individual voices in the human brain, and again, a similar area has been found in monkeys. Humans are famous for engaging in cross-modal integration, in integrating what they see when someone speaks with what they hear, and this has also been found in monkeys. For example, in this particular study, if a rhesus monkey hears the vocalization of another rhesus monkey that it's familiar with, that activates activity both in the auditory cortex and in the visual cortex, as if the monkey is imagining the individual that whose vocalizations it's hearing. There are a lot of parallels there in this complicated cross-modal matching. There's homologous mechanisms for gaze following and joint attention. A couple of recent papers have investigated this in monkeys and humans. And there's also evidence that in monkeys, as in humans, monkeys are attentive to what a particular vocalization signals about the environment, and they can put together two vocalizations that are acoustically very different, but that refer to the same thing, just as we put together two words that may be synonymous, but that sound very different. And finally, there's homologous mechanisms for the recognition of objects. Humans have a particular way of encoding objects, familiar objects in their brains, and as people at NIMH have pointed out, there's a homologous system in non-human primates and humans for representing object information. Now, I think all of these homologous brain mechanisms are important because they're unlikely to have arisen by accident. Instead, the most reasonable way to explain why they are the way they are is to posit that at some point during their long evolutionary history, humans and non-human primates faced similar problems in the environment, and they evolved similar neural mechanisms to deal with those problems. So we're starting with these homologous neurophysiological mechanisms and assuming that they're there for a particular reason, and the reason is that they have shared in the past some social function. So I want to talk now about continuities in the social function, the way humans use language and the way non-human primates use vocalizations. And to start with the human perspective, I'm going to borrow from Herbert Clark's book, Language Use, where he points out that language is used for social purposes primarily. It's a type of joint action, a mechanism for coordinating activity between two individuals. It always involves a speaker's meaning and an addressee's understanding. Those two can be different. Speakers can mean one thing, the addressee may take it to mean another. The basic setting is face-to-face conversation. He points out that language use often has more than one layer of activity when two people talk about events that are going on elsewhere, separate from them. And finally, he mentions the idea that the study of language is both a cognitive and a social science. That is, you can talk about the social function, but that also brings you face to face with the way in which people think about what others mean when they communicate. So with this as a background, I want to talk a bit about some of the work that Dorothy and I have done over the years on communication in one non-human primate, baboons, that we've studied for 16 years in the Okavango Delta of Botswana. Just to give you a bit of the ecological and social background, there's Botswana in South Central Africa, and the Okavango Delta is this amazing wildlife area in the northwestern part of Botswana. It's an open savanna, but every year rivers in Angola bring floodwaters down into the delta, and it takes an area that was dry savanna and floods it with water that's roughly to the depth of your knee or so. And the baboons at this point move through their habitat by wading or running or riding on the backs of other baboons, and they move from little isolated islands that are a little bit higher in elevation from one to another. And gradually the waters go down, and then the baboons are moving through a sort of traditional open savanna woodland where it's open plains separated by patches of large trees and woodlands. And for 16 years we followed these animals on foot. We recognize all the individuals in a group of about 80 baboons, and we take data on their social behavior. So here's Ann Ang, one of our postdocs. These baboons are just resting, they're not dead, and she's taking data on who does what to whom, and we collect a lot of information on their social interactions, and have done this more or less every day of every year for 16 years. Just to remind you of the social organization, the baboons live in large social groups, 50, 60, 70 individuals and more. When a young male reaches close to adult size, about age 6 or 7, he leaves the group where he was born and joins another group. And males may switch from one group to another 3, 4, or 5 times during the rest of their lives. On the other hand, females, when they're born into a group, they stay in the group where they were born throughout their lives, and they form close social bonds with their mothers and their sisters. And if you came out and watched the baboons with us and you learned to recognize individuals, you'd notice that in every group there's one adult female who, as she marches through the group, the others sort of step aside. It's not that she's aggressive, they just sort of defer to her. And if you stayed on for 4 or 5 years and followed her offspring, you'd find that the offspring of each mother acquired dominance ranks directly below those of their mothers. So what you have in baboons is a matrilineal society in which there are families, and the families have within them individuals who are rank ordered. So it's a sort of nested hierarchy of matrilineal families and a linear dominance rank order. In this sort of setting, the relationships are simultaneously cooperative and competitive. That is, females will be good friends with other females, and they will also compete with one another to maintain dominance ranks. Lynn, find a seat, please. Sorry, it's just a great opportunity to welcome old friends. So in these groups, the relationships are complex because they're simultaneously cooperative and competitive. The members of the same family groom with each other a lot, they form alliances, they defend their rank against other families' ranks. So it's a mixture of competition and cooperation. And this is what biologists would call a low reproductive skew society. That is, all the females have more or less similar reproductive output throughout their lives. So what about vocalizations? How do vocalizations fit into this? Well, there are two things that I want to say about the way baboons use vocalizations just to start. And the first is that the calls are individually distinctive. So what I've done here are pictures of 6 of our females in the group. And next to each female, I've put a sonogram of the baboon's most common vocalization, which is a grunt. They grunt to each other all the time when approaching, when foraging together. And so what I'm going to do is play you 2 grunts from each one of these females. Sorry. Sorry, my hands are shaking. This is obviously a sign of old age. I'll get to them later on, but I'll play you the grunts later on. So the first thing is the calls are individually recognizable. The second thing is that baboons follow certain rules in who you can give vocalizations to. So grunts, you can give grunts to anybody in the group, up the hierarchy, down the hierarchy, family, not family, whatever. Screams are only given by lower ranking animals to higher ranking animals. Fear barks are also only given by lower ranking animals to higher ranking animals, whereas threat grunts are only given by higher ranking animals to lower ranking animals. And these rules are quite strictly followed, and what this means is that if you're a baboon sitting and feeding in a bush and you hear a sequence of vocalizations over there, because you can recognize the calls and because you know about the rules of call delivery, you know a lot about what's going on, just by virtue of what you've heard in the calls. And that will come up later on when I talk about some of the experiments. So how do they use these vocalizations? Baboons, let me give you an example. In a hierarchical society where the relationships are a complex mixture of competition and cooperation, whenever 2 animals come together, there's a certain uncertainty because the best strategy for one depends on what the other does and vice versa. And the point of vocalizations under these circumstances is to remove some of this uncertainty, to sort of make the interaction facilitate a little bit better. Here's an example of what I mean. When a new baby is born into the group, so here's a day-old baby, other females in the group are really interested in touching, handling the baby, grooming the mother, so there's a lot of attention put on this new baby and the mother. Mothers, on the other hand, are somewhat reluctant to let other animals handle their babies, and so they often turn their backs or move away. So in this respect, this intense interest in babies creates a conflict. The animals are not in agreement about what's going to happen. On the other hand, baby handling happens all the time. Everybody does it, family, non-family, and it's often associated with grooming, which is a very friendly behavior. So baby handling is, in that sense, a cooperative activity. So since there's an element of competition and an element of cooperation, how did the animals overcome the uncertainty in this sort of interaction? Well, one of the ways they do it is by vocalizing, that is, giving a grunt. So the animal who's approaching the mother with a baby will give a grunt as it approaches. And if you look at the probability of friendly behavior when there's a call or no call, you can see that friendly behavior is much more likely when the approaching animal gives a grunt than when it doesn't. And the probability of a supplant when the mother moves away, that's diminished if the approaching animal gives a call. So how does this work? Is it just that the sound of grunts makes you relax and is more relaxing? Well, Joan Silk and Robert Boyd tested this hypothesis against the hypothesis that what the grunts are doing is signaling information about what is likely to happen. And what they found, this was in rhesus monkeys, similar sort of social situation, that when the animal approaching gave no vocalization, the probability of that animal being aggressive was much higher. On the other hand, if it called, the probability of aggression was very low. The probability of subsequent grooming was much higher if the animal gave a grunt. So what is going on is that these grunts are what we call honest signals. They truthfully indicate that the approaching animal has friendly intentions, is unlikely to be aggressive, and very likely to groom. And this is important because the grunts serve as a way of reducing the uncertainty in the interaction and creating a situation in which the interaction would occur. And Joan and Robert then developed a more mathematical model that generalized to a variety of situations. And they argued that these kinds of honest, low-cost signals can evolve in a variety of different conditions, regardless of whether the individuals involved are competing, cooperating, or whatever. The important thing is that they will interact over and over many years. And this is an interesting general result because these are exactly the conditions that hold in a group of baboons, where females live with their close kin and with other individuals for 20 or 30 years. So the first thing to say is that vocalizations help resolve uncertainty in these interactions. The next thing to say about the way the vocalizations function is that a baboon seems to know when another animal is vocalizing at her. Here's an experiment that begins to get at this idea. So what we did is we waited until a certain social event happened. B1 threatens C2. And what I've done here is I've used letters to denote families and numbers to denote the individuals within families. So B1 is the first ranking individual in the second family, and C2 is the second ranking individual in the third family. So you wait until something like this happens. And then, when the animals separate, we hide a loudspeaker in a bush and we play the threat grunt from B1 to C2, who is now separated. And we see what C2 does. And if after a threat from B1, C2 hears a threat grunt from B1, it responds very strongly. It moves out of the area. It treats this threat as a renewal of aggression between the two. But if B1 has recently groomed with C2, C2 simply ignores it. Acts as if, well, B1 must be threatening somebody else, elsewhere. So what this means is there are a couple of ways you can sort of parse this, is that when two individuals engage in an aggressive encounter, or in grooming, on the other hand, this creates an expectation in the individuals that the relationship will develop along similar sorts of lines. Grooming makes a recipient imagine that the other animal is unlikely to be aggressive to it. So if it hears an aggression, it sort of ignores it. On the other hand, this is treated as renewed aggression. There's an even nicer example when you consider the phenomenon of reconciliation in baboons. We noticed early on that one animal would threaten another animal, and then before the recipient moved away, the first animal would give a grunt. Ugh. and the other animal would just relax. You could see everything was sort of toned down, and we were really interested. We saw this about 10% of the time we saw a fight between two individuals, there would be a reconciliatory grunt. And we really wanted to know whether the grunts were, in fact, reconciliatory signals. So here's the experiment we devised. We waited until B1 threatens D1, for example, and then the animals separate without reconciliation, and then we had a speaker in a bush, and we play to D1 a grunt from B1. And see what B1 does, see what D1 does. And as a control condition, several days later, we would play A1's grunt. And what happened was, if we played this grunt mimicking reconciliation, it turned out that this changed D1's behavior. D1 would approach B1, its former antagonist, or it would tolerate B1's approach if that individual approached it. If you played A1's grunt, there was no change in D1's behavior. Now, it gets a little bit more interesting because in some cases what would happen is that one animal would threaten another, and then a third individual, kin to the original aggressor, the mother or the sister, would come over and reconcile, almost as if they were reconciling on behalf of their relative. So this happened much more often, and we were interested in whether these reconciliatory grunts by kin of the original antagonist actually had the same effect. So again, here's the same experiment. You wait until B1 threatens D1, then the animals separate, and you play B2's grunt, B2 being the sister or the mother of B1. Or you have A1 as a control. And if you play B2's grunt, it turns out that D1 approaches B1 and B2, or tolerates their approach if they approach her. Whereas with A1's grunt, the control, there was no change in D1's behavior. Now, the interesting thing is, imagine what D1 has got to know for this experiment to be explained. It's got to recognize that this is a grunt, not some other vocalization, that it's B2's grunt, that B2 is associated in some way with B1, its former antagonist, and that because of this association, it can treat B2's grunt as just as effective a reconciliatory signal as it would have if it had heard it from its original antagonist. So there's the meaning of this grunt comes not just from the vocalization itself, but it's built up from the vocalization and the extensive social knowledge that D1 has about the relationships that exist among others in the group. So meaning now is enormously influenced by the context, and the context is influenced by memory and social knowledge of different individuals. And I'll get back to that point again in a little bit. So going back to Herb Clark's characteristics of how language is used, it's clear that in non-human primates, like baboons, language is used for social purposes, that their communication is a type of joint action. It's a device for coordinating activity and facilitating social interaction. Baboons use communication to, we can look at baboon communication and talk about the speaker's intentions and the meaning that the recipient extracts from what the speaker does. The basic setting is face-to-face conversation. Baboons, as far as we can tell, don't communicate with each other about events going on elsewhere, so this is not really a parallel here. But it's also clear that as when we study language, we study both communication and the cognitive mechanisms that underlie it. When we study the communication of baboons, we study not only the communication itself, but the cognitive mechanisms that have to be at work in order for us to understand how the communication works. So let's talk a little bit more about the continuities and the cognitive mechanisms that underlie communication. When you think back to the social setting for baboons and you say, well, you know, here is this social structure, this hierarchical structure that I've created, That's really what a human sees when they look at baboons, and humans can create this hierarchical structure, but the real question is there any sense in which the baboons recognize rank orders and families and make some sort of hierarchical structure? Well, we do know from a variety of experiments that baboons recognize the associations that exist among others. You could see from the reconciliation experiments, it's hard to explain the results we got without assuming that D1 knows that B2 and B1 are associated with each other. And if you do that experiment over and over again with different kins, it's clear that they recognize the kin relations that exist among others. If you've got a couple of baboons sitting together, a couple of baboon females, and you play from a hidden speaker the sound of a squabble between two juveniles, if the juveniles are not their offspring, they don't do much of anything. But if one of the juveniles is the offspring of one of the females, the other female will look at the mother as if to say, that's your kid, what are you going to do about it? So it's fairly clear that they recognize the social relationships that exist among others, and we also know that they recognize other animals' dominance ranks. It's not that just that a female in the middle of the hierarchy divides the world into two groups, higher ranking than me and lower ranking than me. In fact, there's evidence that a female in the middle of the hierarchy knows that 2 outranks 3, 3 outranks 4, etc. And this is interesting because this kind of knowledge can only be acquired by observing other animals and making the appropriate deductions. So the question then becomes, if baboons recognize other animals' ranks and they recognize their family associates, do they put it together in something that we could think of as a hierarchical arrangement? And to do that, we did the following experiment. So we did a rank reversal experiment, but we did it in 2 different ways. In one way, we did a within family rank reversal. So 5 threatens 4 and 4 screams. And that signifies, given what we know about the way they use vocalizations, that 5 is rising a rank above 4. But that's within the B family. We also did an experiment in which 3 threatens 2 and 2 screams. And this is interesting because it potentially signals for baboons a major social upheaval, because these ranks are incredibly stable for 20 or 30 years as far as we can tell, but when there is a rank reversal across families, the whole family rises in rank together above the others. And what we found is that if you do a within family rank reversal, the animals look over, they're a little bit surprised. But if you do a between family rank reversal, they look for much longer. They're really strongly surprised. So it looks like the baboons put together their information in some kind of hierarchical structure in which the ranks and the families are nested in one another. Now, why would this be advantageous? What does a baboon get by being a kind of social voyeur and taking note of all the interactions, all the relationships in the groups? Well, there's some recent evidence indicating that in a number of primates, it helps to know about the relationships that other animals have with each other. For example, in chimpanzees, in the long-term data from Gombe, high-ranking males did better than low-ranking males in terms of their reproductive success. But the males who did the best of all were males who formed coalitions with those other males who didn't form coalitions with each other. So a really skillful high-ranking male forms coalitions with individuals who are rather loners and don't interact with many others. In baboon females, it's just the opposite. Females do best if they have really strong bonds with other females. But the females who do the very best of all are the females who form strong bonds with other females who themselves have strong bonds with lots of others. Sort of high eigenvector centrality. And there's a real possibility that this sort of third-party monitoring is adaptive because it helps you form better social relationships, but it's also may have fostered and encouraged this kind of thinking in an organizational way about the relationships that exist among others and the communications between them. And I just want to dissect one of our experiments to say a little bit more about the sort of language like cognition that's going on. So in these rank reversal experiments, what you start off with is a naturally occurring event. So there I am, the baboons are all around, and I've got my microphone on, and what I hear is a sequence of threat grunts and screams from two individuals. In this case, it's Sylvia, a high-ranking female, threatening Hannah, and Hannah screaming. So you can see the threat grunts are right in here, and the screams are much louder there. And this is a perfectly normal thing that happens because Sylvia is high-ranking and Hannah is not. And it turns out that if you then take this and you preserve the bout structure, you preserve this sort of sequence, but instead of Sylvia's threat grunts, you put in Hannah's. And instead of Hannah's screams, you put in Sylvia's, so that it sounds like Hannah is threatening Sylvia and Sylvia is screaming. You get a very strong, surprised, violation of expectation response from the animals who have heard this happen, because Hannah cannot threaten Sylvia, and Sylvia is not going to scream to Hannah because their ranks are so very different. So there's an example of the experiment. What can we say about it? Well, the first thing we can say is that each acoustic element in this sequence carries its own meaning, in the sense that that is Sylvia's threat grunt. It's recognizable as a threat grunt. It's recognizable as Sylvia's threat grunt. And we know that that's true because if we swap Sylvia's threat grunts with somebody else's, we get a different response in our playback experiments. So each acoustic element has its own meaning, but the meaning of the sequence is much more than the sum of the parts. It's a narrative event. Sylvia is threatening Hannah, and this is causing Hannah to scream. We know that we assume that the sequence is interpreted as a narrative that includes causality, because if Sylvia's threat grunts and Hannah's screams just occurred together for random reasons, because Sylvia was threatening somebody over there and Hannah was screaming at somebody over there, then reversing the sequence wouldn't make any difference. The reversal only elicits a surprise response if you assume that the listener is thinking Sylvia's threat grunts caused Hannah's screams to occur. So the sequence is interpreted as a causal narrative with an actor, an action, and an animal who's acted upon. So when baboons hear a vocalization or a sequence of vocalizations, we can now conclude that they form a mental representation of what the call or calls mean. That this is done instantly, that it's a characteristic property of the baboon mind. It's how baboons interpret these sequences of sounds. And the representation of meaning is based on a number of discrete properties. The type of call, the identity of the caller, the kin relations of the caller, the dominance rank of the caller, and ditto for the recipient in those. And these discrete properties are combined according to the rules of call delivery. You can scream up the hierarchy, but you can't give a threat grunt to a higher ranking animal. It's a discrete combinatorial system of interpretation. And it produces a communication system that, first of all, is rule governed. There are rules about where you can use different calls with what individuals. It's open-ended. So if a baboon in a group of 80 can distinguish between, on the one hand, A threatens B and B responds, versus B threatens A and A responds, and it can do that for every possible two-person, two-baboon pair in the group, it can do it for an enormous number of combinations. And if you consider that they incorporate new males that come into the group, New infants that are born into the group are slotted in with their families. Essentially, what we're dealing with is a system, a very simple system, one that is entirely open-ended. So animals comprehend a huge, potentially huge number of messages from a finite number of signals, and their incorporation, their interpretation of these signals includes causality, actor, action, and acted upon. Now, in linguistics, linguists often talk about pragmatics as the subfield of linguistics that studies how context contributes meaning. And taking this definition, primate communication obviously constitutes a rich pragmatic system in which the meaning of calls is enormously enriched by the context. And the context is what exists in the mind of each baboon as it listens to these vocalizations and incorporates them into what it knows about the families, the dominance ranks, the past behavior, and so on. Semantics and syntax are really pretty rare in this situation. We just don't find them, but their cognitive precursors are present in the way that individuals interpret these sequences of signals. So pragmatics seems to be really common in non-human primates. Semantics and syntax seem to be rather rare. So when we try to think about the earliest stages of language evolution, it seems like semantics and syntax came a little bit later, and they were built upon a foundation of rich pragmatic inference. That is, the thinking came first and the communication came a little bit later. Now, the first thing to say about this hypothesis is that it's really not an idea that's original to us. There have been a lot of people who have talked about how the grammar in language exploited mechanisms that were originally used to form various sorts of concepts. The conditions for subsequent development of language were set by the evolution of conceptual structure. But these authors and most other people have never answered the question, concepts about what? What do they want to form concepts for, and why should they do it? There are actually three candidate conceptual precursors of language that people have talked about in the literature. One is number. We know that non-human primates have a rich system of number that parallels in many ways the system of number used in human children. We know that orientation and navigation constitute a system of conceptual thinking that incorporates different discrete elements. And then the argument that I've been making for social cognition. But I think social cognition really is different for the following reasons. That only in social cognition are the discrete elements living creatures. And they're living creatures to whom we attribute motives and goals and objectives. So bound up in this discrete structure is theories that the animals have about what another individual is intending to do. Does that animal intend to communicate with me? Does that animal intend to fight with another? And so on. Also, in social cognition, the discrete elements are explicitly linked to vocalizations. And one thing that we know about the later emergence of language, and certainly modern language, is that language and thought are intimately bound together. And so what we would expect in a precursor of language is a system in which cognition and communication are so tightly bound together that you really, you can't talk about one without talking about the other. And I think if we take a sort of perspective from social cognition, we can start to answer two really interesting questions that linguists have asked about the evolution of language. Len Tolmie posed the question, he says, a crucial bottleneck was overcome when our ancestral communication changed from analog to digital. Where did language get its digitalness from? And my answer to that is that pre-linguistic ancestors perceived calls, individuals, kin groups, ranks as discrete elements, and they combined them to generate meaning. So understanding social life requires discrete compositional thinking. And this is long before the things we think of as language's elaborate properties have appeared. Another question that people have asked about the origins of language, Jim Herford says, Are propositional structures elements of the structures of language, or did they somehow exist before language in some domain outside of it? The propositional structures being the notion that an individual recognizes that a certain entity has intents, beliefs, or has goals as far as another individual is. And again, my answer would be that propositions expressed in language didn't originate with language. In fact, they were there long before language as we know it appeared. They rose instead because to succeed in a primate social group, one must understand an elementary form of propositional relationships. You have to think in terms of animals with intents and knowledge relative to others. And this happens long before you have anything like language. So we're left with non-human primate communication as a sort of oddly asymmetrical system. From the perspective of production, we're still back to the same old things, a pretty small repertoire of calls, not much modifiability, and so on. But when it comes to perception, there's almost an open-ended ability to learn new sound-meaning pairs. The meaning is learned, it depends on experience. The animals don't make call combinations, but they hear them all the time, whenever they hear two individuals interacting with one another, and at that point they integrate a huge bunch of discrete information that yields potentially an enormously large repertoire of meaning. So not so much like language here, but a lot of interesting precursors in that case. So just to summarize, we study primate communication because it offers an approximation of what our ancestral communication was like before it became language. Communication in our evolutionary history has always been inextricably embedded in social behavior, social relationships, social categories, and memories of past events. Baboons face a problem. They've got this small repertoire of signals, but they've got really a rather sophisticated, complex society in which they need to use them. In response, they've evolved a rich system of pragmatic information, inference, digital coding, attribution of intent, and propositional thinking. A lot of the precursors that we can think of as precursors of semantics and syntax. So during evolution, cognition and comprehension preceded production by a long way. And of course, the transition to flexible production would be a major step. But when it happened, there was already a lot of cognitive machinery in place to lead it to something that is more like modern language. Thanks very much. I'll see if I can stop myself from. But if you want to hear the calls, just let me know. Yes. Yeah.
Thank you so much for the talk. That's really interesting. I largely agree with your account. It sounds very plausible. But I wanted to press you on one issue that you said at the end, that the meaning of these combined signals, whatever you call them, the combinations of sounds, is learned. I wonder if you would make a distinction between, so if you say the cup is on the table, there's a sense in which I get information from that, right? I now know that the cup is on the table, but it would be odd to say that I learned the meaning of the cup is on the table from hearing you say that, right? And so I just wanted to press you on the issue because it sounded like that you said that every time a new combination was created, something new, a new meaning was learned. And it sounds like they actually just know the meaning of the individual elements, but that the information that they get is inferred from the combination, but that they're...
Yes.
Do you see what I'm saying?
Well, what I was getting at is, so where does the information come from? Well, if a huge component of the meaning comes from the contextual information, what the animals know, you can't be born knowing how Sylvia's voice sounds. You've got to learn it. And so you've got to learn who belongs to which family, So the information that is encoded in these different vocalizations has to be learned. It's not a sort of hardwired system. That's what I was getting at. And now it's really an interesting question to ask, well, how far do we want to go with cognitive biases in learning? Is it the case that a baboon infant, long before supposing we could do a thought experiment and ask a baboon infant, how do you see the group? Is that infant going to be able to say, I'm thinking rank orders and matrilineal families? And a gorilla infant born in a rather different society is not thinking about that because there aren't so many rank orders and there's just this one male silverback. So has natural selection created a situation in which we are innately inclined to see the world in certain sorts of ways, or do we just learn it and learn it fast? That's what I was getting at. Yes.
Sorry, I got my cough. Fantastic. This is such a wealth of knowledge that you've gained by these experiments, and just I want to thank you for this great presentation. The framing that you put in place about how one of the common features that you see in the vocalization systems are coordinating interaction, reducing uncertainty. And you showed all of these parallels between, in this case, baboons, and the ways that their communication is structured and interpreted based on this larger social context of the communication. And it lends itself to thinking that what really would be a driver of some greater elaboration of a communication system, or an increase in the combinatorial scale of a communication system, would be an increased amount of uncertainty among individuals. So that if you have more uncertainty, it's a harder job to coordinate. And so perhaps that would lead itself to a more elaborate communication system. You had that experimental example of how communication shifts with direct visual contexts versus when an individual is not seen in visual range. I was wondering if you could discuss a little bit more, if you have any other insights into that relationship between, say, spatial cohesion between individuals and the kinds of ways that impacts the elaborateness of communication, or the job of coordination specifically that's being achieved.
It is something that people are thinking about. So let's compare, baboons go around in a group. Everybody's there together. Chimpanzees are very different. They have this fission fusion society in which if you go into this large area, you'll find the same individuals, but they're forever shifting and moving around. And so that creates a situation in which an individual chimpanzee comes across another, and if the first chimpanzee knows something, it's got to figure out whether the other animal knows it as well. There's an added element of uncertainty. So you might think that a fission fusion society would yield some greater cognitive complexity, and at the moment we just don't know enough about it. So Kathy Crockford and Roman Wittig, who have been working in the Thai forest, have done some really nice experiments on the way in which chimpanzees use communication and recognize each other's relationships. It doesn't, with one possible exception, it doesn't seem to be fundamentally different from that you find in baboons. A lot of the explicit experiments that Kathy and Roman have done on chimps replicate experiments that they themselves did on baboons with us. And so that's interesting because chimps have much bigger brains than baboons. They live in this complicated society, and yet there's nothing that leaps out at you immediately that makes their communication fundamentally different. So there are two possibilities. We haven't looked closely enough, or it really isn't fundamentally different, and we're not quite sure what all this extra brain is for. Yes?
Certainly the evidence that you presented is entirely consistent with your thesis that social cognition is the pre-adaptation for language. Maybe phrase it succinctly that way. But it seems to me that the test then, or at least some tests, lie outside of the context of discovery where you made this argument. So two places, and maybe there are people in this room who have the relevant expertise, I certainly don't. Two places where we might see that architecturally. So if, social cognition is the phylogenetic precursor for language, then we would expect serial homology between brain areas used in social cognition and brain areas used in language, even when the language is not about social relations. Right? And secondly, we might expect in language use the social element to creep in or to bleed over such that people treat as agents objects in the world that are not agents, and that you see that in convergent evolution across languages where there's the implicit or explicit attribution of agency because it's built on top of social cognition. So I wonder if you've entertained these possibilities before and if you know of the relevant work in other fields.
Addressing the second one, there certainly is a lot of work in the way in which humans tend to agentize things that are objects in their environment. That we anthropomorphize, rocks, trees, deities, whatever. And so that would be one area of investigation. And the other about brain mechanisms is I'm really not qualified to answer that, but I am struck by the way in which a lot of the work on brain mechanisms in complex cognition is not in the social domain. It has to do with object perception or other sorts of perception. Let a cognitive neuroscientist answer that. There certainly is an interesting phenomenon in perception where, imagine those experiments, you've probably all seen them, where there are two colored balls moving around in an environment with a bunch of other colored balls. And all you have to do is make the movement of the two blue balls that are different from the others correlated with each other to 0.4 or something, and people will say they're following each other. They impute causality without any explicit information that the causality is there. And they do it by moving from correlation to causality. And so that's another bit of example that we can be inclined to agentize things on the basis of not perfect evidence. Yes?
Yeah, so thank you for this really interesting talk. So I just had a question about, so a lot of times linguists talk about these kind of big, big five features that make up human language, namely duality of patterning, so the ability to use two different types of patterning to create novel types of sort of meaning, and then also things like the arbitrariness of the sign. And I think the big one that gets talked about so much in linguistics is recursivity. And I'm wondering if this work has anything to say or can make any intervention in what I kind of perceive, and maybe this is obsolete and I'm just not aware of it, but the problem of the neural kinds of structures that support those sorts of linguistic functions, and then the development of the vocal apparatus that makes having those things useful in the first place. I've always kind of understood linguists, as you kind of mentioned at the beginning, to kind of throw up their hands and say well, there's this big gap between primates and between the emergence of these features, and how do, I guess in an evolutionary framework, how do we explain these two things developing?
Well, let's put aside the vocal apparatus for a minute. And so You know, when an evolutionary biologist looks at a particular trait, they often distinguish between the adaptive features that gave rise to the trait when it first appeared and the adaptive features that cause it to persist once it has evolved and changed. So when the eye first appeared, it was just a primitive light receptor. All it did was tell you whether the sun was up or not. And it didn't have anything like the beautiful properties that a fully evolved eye had. So I think that when you try to develop hypotheses about the earliest stages of language evolution, and I mean the earliest stages, don't jump into something incredibly complicated like recursion or subject-verb agreement or the subjunctive or any of these other things that linguists really like to talk about. You should start saying, show me a system of communication that has none of language's properties, none of fully evolved language's properties, but has some other seeds that might push it in that direction. And so I think it's you know, the thing is, language is fascinating and linguists are fascinated with language, but they aren't very fascinated with baboons. And if they want to talk about evolution of language, they should really get interested in systems of communication that meet none or very few of language's properties. As for the speech, there was a long-held view that non-human primates really don't have the appropriate physiological apparatus to make the kind of sounds in language. There's a really good paper by Asif Ghazanfar and Tecumseh Fitch in Science talking about how that's not really the case, that what does seem to be the difference is the links between particular brain areas and the motor mechanisms used. And so the problem is more in the brain than it is in the speech apparatus. Yes?
It's really fascinating. My question has to do with the infant baboons and the process of becoming communicatively competent in these various kinds of calls. And at what point do we start seeing these kind of incipient kinds of calls? Are they the grunt calls? Are they, you know, what, or I mean, if you've looked at any of that progression. And also, I'm very curious about error correction or of any sort. It doesn't have to be like sort of like grammatically correct or whatever, but
Right.
yeah.
So in most primates, when infants start to vocalize, the calls are not fully formed, beautiful, acoustic, scaled down vocalizations. They are often kind of messy, but you can really see the infants getting a little bit better at producing the different calls. So there's a sort of gradual development of that. That's in the area of speaking. The usage, the ability to use the calls in the appropriate context, that takes longer to develop. And it probably takes longer to develop because in the social domain, you need to learn to recognize the relationships around you because you can't give this vocalization to that individual. But thinking about some earlier work we did on vervet monkey alarm calls, so vervet monkeys have an alarm call for leopards, alarm call for eagles, an alarm call for snakes, and when infants start giving these calls, they make mistakes, but they make sort of within domain errors. They give eagle alarm calls to other birds flying in the air. They give leopard alarms to leopards, lions, cheetahs, that sort of thing. And gradually they narrow it down. Do they narrow it down by error correction? Not really. You know, at first we got very excited because an infant would give an eagle alarm call to a pigeon, and the adults would look up, see the pigeon, and go back to what they were doing. Whereas if an infant was the first to give an eagle alarm to a martial eagle, the real predator, the adults would look up and they would give eagle alarms themselves. This seemed great, you know, they were reinforcing the correct alarms. But in fact, it turns out that if an adult makes a mistake and gives an eagle alarm to a stork and the adults look up, they don't do anything there. It's just that adults give eagle alarms to martial eagles, full stop. You know, they aren't going out of their way to reinforce the infant's correct alarms. And that is similar to the development of tool use in chimps, the development of termite fishing in chimps. Adults are there, they're doing the adult thing, they're very good at it. The infants watch, and eventually the infants learn, but the adults don't take explicit steps to teach them. So it's a longer process. Yes?
To follow up on that, so that's the development of the production of the signal. What about interpretation? How long does it take them to figure out?
So again, we've done this best with the eagle alarm calls, because if with the vervet monkey alarm calls, because there's an explicit right response. And when an infant is sitting next to its mother, when it's really young, you play the alarm call, the mother grabs the infant and does the right thing. As the infant spends more time away from the mother, play it an eagle alarm call, it'll often look down on the ground, you know, and this is wrong. This is actually dangerous. And eventually they learn to do it right. If they look at adults before they respond, they're more likely to get it right. So in that sense, the adults are there, but it takes a while for them to learn. Yes, Tom.
Is it possible that, along with the social cognition you described, cooperative child and infant care and socially distributed care of infants and children? You mentioned this where the infants are shared around, they're in a cooperative group, the females are watching out for the other infants, their aunts and cousins and siblings are participating in that system, led to some of the social cognitive skills, which in turn provide the foundation for the development of communication and language. In other words, is the hypothesis that shared or distributed care was one of the evolutionary pressures which, once selected for, led to these social cognitive skills, also then related to communication and language?
I think that's almost certainly true. We can't imagine doing an experiment because it's hard to raise a young primate without this kind of cooperative distributed care. But that's got to be playing a role because it gives a developing infant many more opportunities to interact with members of its own family, members of other families, higher ranking families, lower ranking families, and so on. Yes?
You didn't talk about using vocalizations, especially alarm calls, to deceive and to lie to other individuals, which seems like a higher order.
Well, it's certainly something that everybody, you know, often is interested in. But think about it. I mean, these animals are living together in the same group for 20 or 25 years. And if I come up to you and you have a baby and I give a grunt and then I'm aggressive, you're not going to believe me anymore. And other animals that are watching are probably not going to believe it either. I think that it's difficult to lie under conditions in which you have repeated interactions.
Do it to stop if they're losing a fight and they're being chased and it's a very stressful situation. Doing the aerial predator alarm call stops that.
Yes.
Everybody stops and looks up. So it works.
It does, but how often do they do it? You know, my guess is you couldn't do it all the time because the other animals would start to ignore you.
Trick the other animals.
I mean, this is one of the big questions in getting back to, you know, the difference between chimps and others. So, you know, does a monkey who is receiving aggression and gives an eagle alarm think, I'm going to give an eagle alarm? They're going to think there's an eagle, they're going to stop threatening me, it's going to be great. Or has he just learned the contingency, if I give an illegal alarm, they stop? I mean, that's one of the experiments that Kathy Crockford and Roman Wittig have done on chimps, where the chimps are moving around individually and one chimp encounters a snake. And then another chimp comes up. And the question is, what will the first chimp do? Will it give a warning alarm call to the second chimp? And what is it about the circumstances that determine whether the first chimp will give an alarm call or not? Is it simply the first chimp looks at the other's behavior and makes a deduction about what it knows? Or does it have a theory oh, he doesn't know. And devising an experiment that explicitly tests between those two hypotheses is really hard. Yes?
About relationship between the cognition of kin as your understanding and the cognition of friends or coalitions or associates more generally. So I wanted to ask about that specifically in the context of the third-party reconciliation calls and so whether you get those kinds of third-party reconciliation involving non-genetic kin among friends, associates, but also more generally the kinds of discrete combinatorial structures you're describing, you could also apply to non-family relations, to contingent coalition partners. And I'm wondering whether you think there's good evidence for that kind of tracking as well, and its implications partially because of how flexible those because of their contingency, they have to be really flexible. So it's another kind of case of flexible combinatorial cognition. So.
Mm-hmm. So the best studied example of that kind of third-party recognition that doesn't involve kin are when male and female baboons, around the time that the female ovulates, is forming a tight pair bond, and they're going around together. And there's experimental evidence indicating that other animals recognize the association between those two, even though it's an association that doesn't last for very long. Whereas the female dominance hierarchy is really amazingly stable, the male dominance hierarchy changes all the time. And yet, if you do rank reversal experiments and you play a rank reversal test to a female, a series of experiments suggests that the females are really tracking the short-term changes in the male hierarchy. So they know that last Tuesday, number 4 rose above number 3. And if you present them with evidence to the contrary, they show a surprise response. So, but those are patchy, and I think there is some other people doing work on macaques that are looking at what other animals know about the friendships that exist between individuals. And my guess is they know a fair amount. Yes?
Thank you very much for a really convincing presentation. So I'm curious about the role of a relatively rule-like system governing the behavior within these hierarchical social structures. There's interesting work in theoretical computer science on the conditions under which communicative protocols for kind of goal-oriented communication can emerge on reasonable timescales. And one of the properties that plays a role in some of those analyses has to do with the kind of learning theoretic properties of the communicative protocol. So I'm curious whether you think this rule-like social structure plays an important role in scaffolding communicative structure that also evade, like you could imagine a scenario where they were less rule-like, and I'm wondering if that might make them less, that social structure less important as a scaffolding for the emergence of language-like communicative systems.
Well, that's a really interesting idea. And I can, I don't have any evidence that addresses that, but you really want to work across species. So for example, in gorillas, they live in one male groups where you've got one male silverback and a bunch of females, and you can't find a hierarchy among those females. They just don't interact in these predictably directional ways. So does that create problems for rule-based communication? Well, we don't know. Take the chimps in their fission fusion society. If two chimps are coming together, one can't assume that the other one knows everything that it knows, so in that sense it's cognitively more indeterminate. Does that mean that they communicate in different ways? Really good question. Yes?
I want to go back to this idea that you laid out where you propose that social structure is a pre-adaptation to language. And I wanted to ask if you consider, I'm sure other people have sort of considered the alternative hypothesis that language is a precursor to, or a predadaptation to more elaborate social structures. And I was wondering if you could talk at all about what is known about that possibility, and if there's a potentially a role for a feedback between the two, that it's not necessarily one or the other, but that once you get some sort of rudimentary language, that can enable sort of potentially larger social groups, which then require more elaborate communication systems. And if people have considered that possibility of a feedback in this system or other, across other primates or other animals with language.
Well, that also is a really interesting idea. If I take the first sort of 2/3 of your question, we're really talking about differences in time. I mean, I'm talking about an early stage when something is going on and there is a communication system that any linguist would look at and say, it's not language, doesn't have many of language's properties, but in fact the cognitive operations are setting things up so that language can maybe emerge from that. And then, a long time later, you've got an emerging language, and is it going to make social behavior more complicated? The first question is the question I was trying to address. The second question is, I know that people must have been talking about this. I'm only familiar with the debate about the way in which language structures meaning, and whether, if you speak in a particular language and you have words for a particular sort of relationship, it changes the way you see the world. But the linguistic and social complexity, that's a really interesting idea, but that's, beyond my knowledge of language. But my impression is, am I right, Josh? This is a big debate about how language and mind interact.
But you can think about this developmentally too, like how much does, across development, does your theory of mind, like capacities, influence your syntactic capacities and vice versa? That there is work on, for sure.
Okay, thank you all for coming.